and get started. My name's Hector. I'm the Business Development Manager here at Novacoast, and I'll be your moderator. And so the reason you're all here is to learn a little bit more about software-defined storage and what it can mean for you. So we'll be doing a high-level overview and then moving on to a couple of case studies today, proving why people are moving in this direction. After that, we have a live demo showing you the simplicity behind managing your storage, killing nodes, and all that. So we'll end it with a Q&A, and we'll also be doing a raffle for a BB-8, so we'll see who's the winner there. A little background about Novacoast. We're an IT cybersecurity services company. We have over 100 engineers and developers, and what we're really good at is making things work and then adding a layer of security expertise. And that's our biggest differentiator. We're not just advisors on how to make your business run more efficiently and securely. We're also the blue-collared, get-your-hands-dirty implementers and custom developers, and that's our foundation from over 20 years ago. And today we're a multi-layered, one-stop shop for all your security and IT needs. So here's some of the types of industry we work with. From very, very large enterprise, highly regulated customers to smaller shops. We're really able to help any of those. So just out of curiosity, let's go on to the next slide and see where you're coming from today so we can help suit this presentation for you. So I'll give it a second here. We got a pretty diverse group here. Looks like many different industries, government, financial taking over, and some healthcare. Okay. And here's our North America map. We're based globally. We have offices in Canada, Mexico, UK. We're continuing to grow. In America, we have a dozen offices and about 100 engineers and developers. One of those engineers is here with us today, Dan Elder. He's our Director of Linux Services. He's going to be doing our presentation. He's been working on storage and been in the Linux practice for, how long has it been, Dan? Like 15 years?
Yeah, it's been a little while now.
Cool. So Dan, let's get started. Why don't you tell us a little bit about, take a seat and tell us a little bit about what's going on in storage today.
Great. So before I talk about where storage is today, I want to give you a quick glimpse of what it's going to look like in the future. And this is a live demo, and I have sacrificed several chickens, so hopefully everything goes well. But I'm just going to briefly show you here what it looks like when we talk about storage. So this is a software-defined storage demo. First thing you'll notice is I'm running about 6 different VMs, and I'm doing this all off a laptop. So the performance is not going to be realistic. What I'm just showing very quickly is how easy it's going to be to add and provision more storage. So what I have here is this nice dashboard that shows me the state of all the hardware in my environment. And all I've done is turned on a new piece of hardware, in this case a VM. It's PXE booted up off my controller, and it's just sitting here in this state waiting for me to do something with it. So I'm going to go ahead and get this process started, and I'll go back and walk you through the whole business case and everything else after this. But since it takes 5 to 10 minutes to run, I wanted to do this at the beginning of the presentation so you're not sitting there watching it PXE boot later on, because that's not nearly as exciting. So I'm going to make this another storage device. And all this is going to take is just a few different key clicks here. Say it's a storage node. Go ahead, set it up.
Yeah, and I see some questions about what's going on right now. This is just a setup for, and we'll get back to this in about 15 minutes.
Yeah, I apologize. I'm going through this very quickly here because, again, this does take a little bit for it to boot up. I will go through what this web interface does, what all these pieces mean in quite a bit more detail later on. But I just wanted to show you, get this started here, because by the end of this slide deck, I will have increased my storage, and you saw it just took a minute there. So anyway, I will let that run. And I will go back to slides. So where is the state of storage today? Well, this is where people are largely stuck right now. We have a lot of different solutions we deal with depending on what type of performance you need, or depending on what type of redundancy you need, how scalable it needs to be, whether that's SAN or NAS, tape, DAS. There's a lot of different solutions out there depending on what it is you need, as well as how much you want to spend. And so we've got all these different storage tiers to work around the fact that, yes, we would like to put everything in the world on a SAN, but we can't afford that. So the way we deal with that is by having these different storage tiers. And you put the performance optimized storage where it's needed the most, and you try and figure out what you can shoehorn into this lower performance storage to save costs. And a challenge with a lot of these solutions is you get to the place where forklift upgrades, these are just normal procedures. So your SAN gets end of life. You can't really scale it out anymore, even if it's only a year old because a vendor dictated that this is no longer a supported product. You've got to deploy something entirely new and go through all the pain of migrating something as critical as your data, and it's outside of your control of this entire life cycle. So it's kind of a painful way of dealing with storage. Because ultimately, you care about your data, you care about performance, you care about a lot of different things, but if your data is not there and it's not available, that's a big impact to your business that can put you out of business. So where does all this data live? We're talking a lot about data today, and again, I apologize, I'll get more into the demo later, I just wanted to let that run in the background. But going through where our data lives, the Tier 0 and Tier 1, where we've really got our ultimate high performance, whether it's OLTP, databases, something transactional, these are all where we put the SAN as king today. And it's a good fit for SAN. SANs can give you really good performance. The challenge is, of course, it's at a very, very high price. We've got a lot of other data here sitting in Tier 2 and Tier 3, whether it's archival data for compliance reasons or security reasons, or a lot of bulk data, whether it's machine generated or anything else. And this is where the majority of your storage is today. And it's not worth putting on a SAN, but it's something that you do need to make available. You need to have it spread throughout your environment. You need to find a solution that's going to keep that available, keep it secure, and not cost you an arm and a leg, because data growth is enormous. As anyone in IT who deals with storage knows, this amount of growth is not sustainable. We're in a position where storage is growing 40% year over year according to Gartner, but the storage costs are only decreasing 25%. So dealing with 44 trillion gigabytes by 2020 is going to be a little bit of a challenge.
Well, hey Dan, this is Hector. I just had a quick question. When I see this, me being a consumer and I like tech, and I see this as mainly being Netflix, all my Amazon shows, I got Spotify. I don't really see how this relates to, a normal person's environment. Can you give us an example?
Absolutely, it's a great point, because you do see this tremendous data growth in a lot of these .com startup type ventures, or these online media ones, or the big players. And we're going to go through some use cases identifying that growth in various cases. But the reality is every single business is going through tremendous data growth, and there's a lot of different reasons for it, whether it's compliance driven, they're actually required to hold on to these log data or emails or whatever it is, or they're looking at that data and actually generating value from it, either through looking at customer patterns and trends, trying to identify new ways to track shoppers, trying to hold on to financial data to look for fraud patterns, trying to hold on to electronic medical records because they have to keep track of these for up to 6 years. There's a lot of different reasons all this data is growing, but at the root of it is businesses don't want to give up their data. There's a lot of value to be derived from data if you use it effectively, and so people are realizing that and holding on to this more and more. So sometimes it's a new use case, sometimes it's just realizing there's value from an old use case, but the reality is every single environment is undergoing tremendous data growth. So 40% sounds like a lot year over year, and it is. When you look at it month over month, that's not significant. When you look at it, 40% growth year over year, that's getting to be pretty big.
So it's for a 100 terabyte environment, you're saying?
Yes, exactly. Great question. So starting with 100 terabytes, by year 2, you've of course 40 terabytes up, but you see that monthly creep continues to go up as well. And when you look at year 3, again, this is only 2 years have passed since you started, you're almost double your storage. So 40% growth is a massive amount, and with most IT budgets today, that's unsustainable. You can't keep buying things and doing things the way you've done them before. So the whole point of this webinar today is we're going through to look at software-defined storage. So where does software-defined storage fit? And we'll get into the technical pieces later as well. Software-defined storage meets a lot of different needs, whether it's long-term storage needs, you've got your data archiving, you've got a lot of unstructured data out there. Whatever it is, you need to hold on to it either for compliance reasons or it's some type of use, or people just don't like deleting data. And that can come back to haunt you. Data classification is an important thing so you can know when to expire data. It shouldn't live forever in most cases, but most shops aren't there yet. They haven't reached that security maturity to be able to do that effectively. So for now, we hold on to that data. You've also got all these new and growing storage needs, whether it's bulk data being generated by machines, it's like log information, debugging information. There's a lot of different reasons that you can see that going on there. So other things you can look at, disk to disk. That's another one where we've got all these high-performance applications running in our Tier 0 and our Tier 1. And that's being used, of course, for that mission-critical business application, whether it's processing credit card transactions or doing biomedical studies. Whatever it is, you need that absolute performance available. But for development purposes and testing purposes and diagnostic purposes and backup purposes, you might want some type of streaming copy of that data to a secondary environment that can really be able to be used by everyone else without impacting the performance of your production environment. That's another great use for software-defined storage. Or if you've got some type of cloud deployment, whether it's something like VMware or Xen, KVM, Azure, all these different things all tie together, and we're going to give you cross-hypervisor compatibility. Then, of course, Hector brought up the point of things like Netflix. But Netflix isn't the only organization that has these huge video libraries or these huge audio libraries. Hospitals, of course, have to store all these different medical images, whether it's an X-ray, an ultrasound, any type of video, things like that. And then every organization out there is putting up cameras everywhere. It's not just police body cameras, it's surveillance cameras in buildings. A lot of schools are dealing with this, a lot of universities. So I see a lot of organizations that have this huge growth of data from a new need, where previously something like video was a whole different department. It wasn't IT's responsibility, but now that it is, we've got to figure out where to store all those things. So software-defined storage is going to give us a very cost-effective way to deal with that.
So Dan, have we found any specific industries, with our security work that have been interested in some of this?
Yeah, it's a great question. So I'll go through a couple of use cases here, and that poll earlier helps me tailor this too. But so one good example we always talk about is healthcare. Healthcare has got a lot of expected data growth, and there's a lot of reasons for that. Electronic medical records, of course, are something that are fairly new. Standardizing on them, very important, but those are for every single patient out there. You've got all these medical devices out there that are suddenly networked. You've got this Internet of Things in hospitals that are generating large amounts of data, and whether for FDA reasons or HIPAA or anything else, you've got to now store all this for up to 6 years. You've got to keep a lot of this data available, and you've got a lot of new applications going into place around that are generating a lot of data and storing data, whether it's something they generate or something they access. There's a lot of data out there. Security is a very important one. HIPAA's all of a sudden got teeth, and a lot of organizations in the medical space really need to deal with that. Being able to hold on to those records is something critical, and do it in a secure way. Now, security is not necessarily something that comes out of the box with any type of storage solution, but by lowering your cost of storage, you can focus on securing it. You can spend that budget more wisely on the initiatives you really care about. Storage is something we have to do, but all the other pieces around it are where you derive value to your business.
So, Dan, I have a quick question. I think it's on HIPAA compliance and how those applications, the security applications, help people get to be HIPAA compliant. How does that relate to this storage conversation?
Sure, absolutely. So software-defined storage itself does not solve HIPAA. It doesn't solve any type of security requirement, really. It's still storage. What it can help you do, and sort of alluded to, is if you instead of having to spend all this money on storage, by reducing that cost, you can now spend your money on other efforts like data classification and other security parameters. So there's not necessarily anything specific to a SAN, a NAS. None of those are going to offer you anything different in terms of securing your data. Now that being said, what we're showing today does have data encryption at rest, and I'll be showing that a little bit later on. So you do get to meet some of those requirements with this, but it's not something that's necessarily a solved problem. Security is a voyage. It's not a destination. So by helping you, so data in transit. So good question there. I saw that. Sorry. So data in transit, that's really going to be at the application layer, not at the storage layer. So whether it's through a web application doing SSL or TLS or something else, it's data in transit between the client and the endpoint is going to be interesting. And we'll talk a little bit about iSCSI later on. That's going to be the main transit method for accessing this data in most environments. But those are all good questions. If you'll bear with me for a little bit.
Yeah, and Dan, quickly too, do you have any experience with handling, large logs, that type of data, and like how big was that? And Because I think that's kind of where it fits in, that you have all these new logs and security data. It's managing that data that's really going to save you.
Yeah, absolutely. So that's a perfect use case. So a use case is financials, and I spent 3 years at a large financial really designing and implementing their log plan for them. And the problem there was they had to ingest between 2 to 5 terabytes daily of log data, just raw text log data, and aggregate that globally into a single zone and be able to use that. Hospitals probably not going to generate quite that much log data, although that's changing over time as more and more devices come online. But being able to store that somewhere and be able to deal with it is a challenge. If you don't have the back-end storage solution to be able to handle that at a cost you could afford, you're already behind. But being able to then process and analyze that data, being able to do something useful with it, that's really at the application layer. So the storage is going to give you the flexibility to keep up with all this log data by being scalable, by being affordable. That's going to make it easier to solve that underlying storage problem. But then processing it and everything else on top of it, that comes through the application layer of whatever type of analysis you're doing, whether that's something like Splunk or Elk or Hadoop. I've worked with all those. Those are all good solutions. But then you're looking at full-blown SIEM solutions, which is also an area we work with. But I would digress a little bit too far if I started getting into that space. But good questions. Please keep asking them.
And then real quick too, if the world is going at 40% increase rate, which includes Netflix and Amazon and Spotify and Instagram, what are the predictions in healthcare for data growth?
Sure, it's a good point because that 40% number, that 40% number does take into account the fact that there are those Netflixes and other organizations out there that do a lot of that. But with healthcare alone, it's 48%, so that's already over the average. So that large number doesn't mean that you're storing Netflix. It means that you're just a business out there, and in the healthcare field, 48% is your expected growth. Sorry, I found another great question.
Do you have any examples of, out of nowhere? Because this I can see, it's pretty obvious. You can see the EMR, people keep coming back, patients didn't get updated, any retention laws. Is there any examples of, out of nowhere, you just need all this tons of storage, there's some new technology?
Sure, absolutely. So that's a good use case of, we see this everywhere. These new police body cameras are being widely deployed in response to a lot of different things going on. And the challenge they're having is they're seeing the low cost of the cameras, and they're not seeing the hidden cost of the storage behind it. So we look at San Diego, for example, where they have a $300 camera per officer. That's an easy price for them to digest. It only costs $250,000 for all these cameras. It seems like a great solution until all of a sudden they realize that the storage cost is over $3.5 million. So all these new applications, these mobile devices, everything being deployed, whether it's a governmental organization, whether it's just security cameras in your parking lots, all these things generate an intense amount of data, and being able to store that's critical, but people aren't always looking at that cost. So your managers might be purchasing these new or deploying these new types of solutions without really taking into account what's going to be the total cost of actually maintaining and managing that, and a lot of that's really just the storage side that no one's taking into account. And these are all perfect use cases because you don't necessarily need the highest performance. You just need this data to be available and scalable so that you can grow it out easily and have it be accessible at whatever performance you desire. I see another question there about deduplication. Great question. When I get more into the architecture of Ceph, which is what we'll be showing later on, we'll talk about replication. Dedupe is not necessarily something that's part of this, but great question. I'll get into that more later, and please remind me if I don't answer that for you. So talking about Ceph, what is the architecture of Ceph? Well, a few things to know about Ceph is this is an open source solution. It's been around for over 10 years. It's very mature. There's a lot of organizations behind it. So this isn't something new, but it is something that's really kind of exploded recently because storage is exploding. And so like a lot of other open source solutions, it's grown very rapidly. There's a large community around it, and there's a lot of people very interested and very focused on this because it is a challenge. So it uses Crush for mapping where data lives, and this will get into more technical pieces than probably a lot of you are concerned about. But the way it really works is you end up with smarter clients accessing dumber storage. By making the storage as simple as possible and putting all the data lookups and everything else onto these monitoring systems that have these Crush maps of where data lives, you let the storage do what it does best and abstract things a layer away for the data lookups. And that's what really allows us to scale so well. That's always been the challenge, and that's where Ceph succeeds. So when you look at some of the largest data users in the world, like the CERN Super Collider, this is the architecture they use, is the solution they use, because nothing else can scale and keep up with those data demands. And as you scale up the data, it becomes more resilient, it becomes more robust. So it's a kind of a different performance curve than you're used to seeing too. If you start with a very small number of systems, for example, I'm doing this on a laptop with only 4 storage nodes. The performance is not going to be great. As you add more and more storage to it, though, the performance actually will improve and the data will become more redundant and more robust. So it's a very different architecture than a lot of people are used to in the storage space.
Hey Dan, I think everyone on this call agrees that open source is awesome. I think everyone here's Linux people. My question though is, what about our critical data? What do we do about securing and supporting this data in an open source solution? Is there anything we can do to feel safe and let our boards of directors know we're in good hands?
Yeah, absolutely. So the same way you saw in the Linux space, and a lot of open source projects have gone this route, is there's a commercial enterprise version and there's the purely open source version. So we look at the Ceph architecture itself, and it's really most cost effective at greater than 100 terabyte scale. But talking about going at something where I really want to get something supported, because again, your data is critical. We're going to talk more about SUSE Enterprise Storage. So this is a Ceph distribution, and it's an enterprise-ready one. And all that means is much like their enterprise Linux distributions, there's enterprise Hadoop distributions. It means there's someone standing behind it to support it. And by supporting it, it's not just someone who's there to call. It's someone who's giving you the tools and packaging around it to make it very, very easy to deploy. And that was the start of the demo I wanted to show earlier, is I only had to go through a few clicks on a web page, and I've all of a sudden provisioned additional storage with brand new physical hardware. So that ease of management, that's important. Being able to deploy things rapidly, that's important.
What is that thing in the middle there?
That looks to me, oh gosh, look, yeah, good point, Hector. So just this week, SUSE won, again, Product of the Year award for SUSE Enterprise Storage, which is based on Ceph. They've been getting those awards for a couple of years now. But it's really, when they stack up against the competition, again, it's still Ceph at its core. It's open source at its core. But what they've done is make it very, very easy to deploy. They've made it very, very quick to deploy. And they've also added something else which very important, which no one else has really supported yet, which is iSCSI. Ceph by itself is accessed traditionally through object-based things, APIs like S3 or Swift, and that's great if you have an application that can speak that, if you're using something like OpenStack. But for the rest of us, you need some type of protocol that anyone can use, and that's where iSCSI comes in. SUSE has added iSCSI support for Ceph and supported it so that any type of workload anywhere really can speak to that. iSCSI is a nice standard that just about everything uses, including most SANs and NASs and everything else. And so as far as your application is concerned, it's just speaking iSCSI to a chunk of storage. And by supporting those nice standards, you've really taken Ceph to the next level by making it work with anything. So that's one of the key reasons we're talking about SUSE Enterprise Storage today, is you're getting that enterprise support because your data is key. You want someone who's certified a solution, who's gone through, dug out the bugs. They're not necessarily giving you the latest and greatest of everything, because they've spent the time going through and evaluating what works and what doesn't work. Is NFS support there on the way? Great question. NFS support is not built in currently. It's something you could, of course, easily set up and up. These are all Linux systems, so you can stand it on top and access it through iSCSI or another means. But that is coming. So CephFS, NFS, a lot of those pieces are in the roadmap. And if you don't mind asking that question again at the end, I think there's probably some SUSE folks on this call, and they might be able to answer that as well better than I can. Now, this isn't a solution that we would recommend if it's not something we would use ourselves, and in fact we do use this ourselves. And the reason we went this route is because we did have 2 legacy SANs in our environment that we were either forced to upgrade because our vendor decided they were end of life, even though they still worked perfectly well for us. We didn't have that choice because they'd consolidated. Some of you are probably aware of the EMC consolidation and whatnot. And we didn't want to have vendor control over that. So we wanted to go with someone who can support something open source but has 20 years of experience doing it. We wanted something that was very customizable, very scalable, because our business needs change rapidly. Right now we're building out a SOC environment. That's something we offer to customers, and it's growing rapidly. And we don't know what all that log aggregation is going to look like 5 years from now, let alone further than that. We're still planning that out just for year 1 and year 2. So we needed something that could really change and work with us and not be beholden to what a vendor says fits in our particular use case.
And so this was, did we use SUSE or did we use the Ceph?
So after evaluating both, we decided that, of course, our data is critical, so support is critical. But really, the iSCSI support was also very critical for us because we're going to be accessing this from a lot of different systems, whether it's our virtual environments, but we use something different for just about every workload we have. And we've embraced DevOps for everything, so we use software-defined networking at the top of the stack. When a new workload's provisioned, the switches are automatically reconfigured to allow access to specific network ports. The software-defined storage side, which is SUSE Enterprise Storage, is automatically reconfigured to provision storage for them. All these different pieces happen automatically so that we can be able to see that and have it work for us. And we can't do that very easily with proprietary SAN, but we can do it with this. So good question. Some more details about the DevOps workflow. So this is a good example I like to talk about because, again, I'm a Linux guy. I do DevOps quite a bit. I do Docker quite a bit. But to give you an example of what provisioning a workload is, and this is an even better one, is I will talk about how this worked for us when Shell Shock came out. So we didn't have all the pieces in place, so a little bit of this is jumping ahead to where we want the future to be. But when Shell Shock came out, we had the issue that everyone else did of being able to get that patch out very rapidly. And the reason that wasn't a problem for us is because we had fully embraced DevOps at that point. So to give you an example of what that workflow would look like, the vendor patch hit our patch proxy. The patch proxy saw the CVE severity rating of that patch and automatically rebuilt our Docker containers because we're about 80% Dockerized at this point. So it went through, regenerated that, ran through all the unit testing, all the regression testing, and when that passed, everything looked good, and went ahead and pushed that into production, that Docker container into production. In production, the switches were reconfigured to drain the load balancing or the connection pool from the current production image to the new image. Once that was complete, the switch ports were deactivated for the existing ones. Everything was pointed at the new one. The connection pool had been drained, the load balancer had been automatically reconfigured, and the storage side automatically removed the pool for that legacy environment, and we had everything set up. So in terms of tools that we used, that's a good question. There's a lot of them. I might hold some of that for the end if that's okay, but Jenkins was a big part of that. We used some Swarm. There was a whole lot of pieces there. So I could talk for hours about this. I don't know if it's something everyone wants to hear about, though, so please, if you'll bear with me, I'll talk about that a little more at the end. But yeah, really getting that full automation workflow is very important.
I know we used Chef was one of them, but do you want to talk a little bit about pricing before we get into the demo?
Yeah, absolutely. So pricing.
What's the cost looking like?
Exactly. So at the end of the day, one of the biggest considerations for looking at software-defined anything, whether it's storage or networking, is going to be cost. The cost curve of trying to keep up with storage is just unsustainable. I can't deal with 40% storage growth if my storage costs are only coming down 25% every year. I can't keep going back and asking for more money, and only be providing the same level of service every year. So if we look at the cost, and this is just a Gartner analysis of a typical mid-range array, and the individual numbers themselves aren't going to be too significant. They are broken down in a lot of different ways over everything else. But if you look at your CapEx and your OpEx savings, you're saving over half. You're getting back half your budget from storage that you can now allocate to other projects, such as securing your data, such as automating and provisioning, such as log analysis, such as getting in front of regulatory compliance requirements. This is ultimately about saving money and giving you flexibility and scalability. That's really what software-defined storage comes down to in a nutshell. Another good way to look at these numbers, look at them in a spreadsheet, but again, you're looking at the price per terabyte, how much that comes down, and these numbers are, of course, data. They're from almost a year ago, so those numbers are going to be even lower now. But as that price continues to come down, we're still using commodity hardware, so we can use, for a software-based storage solution, you can use hardware from whatever vendor you want. You can use whatever type of drives you want. If you want more performance, use SSDs. If you want less performance, use SATA or SAS. You can customize each system out exactly the way you want it, drop in a mix mash of whatever vendors you want, and it's all going to come together because it's controlled on the software side. So it's far more flexible. You can't readily do that with SANs. You can't combine different SAN vendors and just cobble things together on the side and do whatever you want. When you're tied into a particular vendor, you're kind of stuck with whatever they want to do and how they do things and what their upgrade cycle looks like and what their end-of-life policies are. You don't get that flexibility you get in the open source world where you can, it's infinitely customizable. Now, the challenge, of course, with things being infinitely customizable and flexible is that they're not as easy to set up usually. That's what goes back, of course, to enterprise vendor support, and the reason that Novacoast is talking today, of course, is we do a lot of services around that.
Before you move on, I just want everyone who's on this call right now to really think about what does it cost you per terabyte, and do you know that answer? Because there's a good chance no one knows what it costs, and if you do know, then you should be looking into something that's and find ways to decrease, because I mean you're not all financial officers, but your CFO cares about this, about how much it's costing for this data. So just a thought, homework for everyone.
I will jump back into the demo, which I went through very quickly originally, but now I'll explain in a little bit more detail. So if I go back to what I have here, this is a tool called Crowbar. It was originally developed, I believe, by Dell. It's open source. SUSE has adopted it as their primary means of deploying OpenStack clouds, and you can actually use this now for deploying storage solutions as well. And what they basically give you is the ability to set up this storage admin node. And what that is it's Crowbar. It's set up for PXE booting systems. So every single system in here, all I had to do was turn it on. I haven't touched any of these systems. As long as I plug them into the right network segment, they PXE boot up, they come into this console, and once they're in this console, I can choose what I want to do with them. I can make them storage devices. Calamari is a web interface, and I will show that in a minute, but I've got these storage devices, which also, in this case, are my monitor nodes. Not the best way of doing things, but since this is a demo on a laptop, you're stuck with the limitations of my hardware, and running 6 VMs is as much as I really want to do right now. I don't want to tempt the demo gods that badly.
Hey, Dan, can you slow down a little bit with your screens? They're kind of flashing because it seems to lag a second. So
I apologize.
When we switch screens, it's a little distracting.
Is the web page showing up correctly now?
Yeah, I think so. You're just a little laggy, but it's okay. Just as long as you go slowly with this.
Okay, perfect. I apologize for that. The hazards of multiple VMs. So
yeah,
if I take a look at
the console, to your console. It keeps flashing your console. Is that intentional?
No, I have no flashing here. Sorry about that. So briefly, if I look at one of the nodes in here, and hopefully this is showing up for you, it'll tell me the processor, the memory, how many drives it has, what I've applied to it. In this case, I've made this a Calamari node, and Calamari is just a web interface for managing my storage. But if I look at what my storage looks like now, and this may flicker a few times for you, you will hopefully see the dashboard for my Ceph environment here. I'm using SUSE Enterprise Storage again for my demo. You can see I've got 4 out of 4 OSDs up. I've got 3 out of 3 monitors. And all that happened automatically behind the scenes for me. I added a node, as you saw at the start of the demo. It's already been joined. Everything is green and happy and healthy. And that's a good state to be in, but that's not very exciting for a demo. So what I want to go ahead and do is just whack one of these nodes. So you can see storage automatically get replicated. So I'll take node 1 here. And I'm in a VMware console now. Hopefully this shows up for everyone. And I will power this off. So I've now removed a storage node from the cluster the mean way, as I often want to do. And I'll give this a minute to catch up because it's going to query everything. It's going to give it a while to time out and try and get healthy. But you'll see that all of a sudden I'm going to go from having everything green to it's going to fail down to some of the nodes are working and replicating. And if I give it just a few minutes here, everything will catch back up and we'll see the storage is healthy again. Are there any questions so far? And I can't see my chat window, so please chime in, or Hector, if you don't mind reading those, that would be great.
Looking good.
Excellent. So you can see that I've now got some of my data showing up as dirty. That's because in here, and I will be gentle as I go through this, and hopefully that will not cause too much flicker. But if I take a look at my storage pools, I can see I've got some of these. Most of these are set to have a replica of 3. So a good question came up earlier about data deduplication. There are different ways in the Ceph architecture to handle data duplication. So for redundancy purposes, you always want at least 2 copies. You can have more than that, depending on how important it is. The default value is 3, meaning you've got the original copy and 2 more. But replication is one way of both increasing availability and performance to a certain extent. You can also use erasure coding if you want. That's kind of like, you can think of it as a generalized RAID 5 at the storage layer. And so you're taking your raw disk capacity, and for example, with a replica of 3, you're cutting that raw capacity into thirds. So you're really only getting a third. And it's the same thing you do with a SAN or anything else. So if you're using RAID or any other technology, you're giving up some amount of storage for redundancy. Software-defined storage. Yes.
Quick question, Dan. Different data centers or same data center?
Great question. So you can modify this crush map to define where that data is replicated to. So for example, in the case of Novacoast, we created a stretch cluster across 2 different data centers, and we have equal hardware essentially in both sites. And our crush map is defined that we have 2 copies of data in each data center. So we've essentially got 4 our replicas 4, and we've got 2 on each side, so that if we lose an entire data center, which sometimes happens due to power outages or other catastrophes, the data is not only on the remote site, but fully redundant on the remote site. And that's not just for redundancy purposes, it's for performance as well, because if I'm going to do a read, I can now do it across 2 different disks instead of just 1. So you also can get better performance by increasing the replica size. But that also is the antithesis of data deduplication. So if you're looking at data dedupe at the file system level, that's something you're really going to be looking more at a different product for, some third-party products for doing data dedupe for backups or archiving. This isn't really something that's going to be native in here.
And Dan, how's this data getting transferred? Is it through VPN?
So you can transfer the data. So the data can be accessed via iSCSI or S3 or Swift type API interface. There's a few different ways you can handle that. Right now, iSCSI is the predominant method of access, unless you've got an application that can actually use S3 or Swift. But yeah, iSCSI is generally what I do. Unfortunately, I don't have enough capacity on a laptop to show all the redundancy capabilities built into this, where you could have it across different sites, using multipath over iSCSI and some of those pieces. But yes, that does work. So as we watch this now, we've seen that some of that data that was originally marked dirty is now in a working state. It is going through now and re-replicating that data to take into account that a node has down.
You might be blacked out here. If is there a black? I see like a big black box right above your virtual machine details. It's just blacked out.
That is inconvenient. Let me unshare and reshare my desktop there. I apologize for that. The demo gods are not being kind to me today. Well, I guess the demo actually worked. It's just my ability to display it's not working. While I do that, are there any other questions?
I think we're good.
Okay, perfect. So I know data dedupe was a big concern. Getting the data security. No, this doesn't solve data security, and while it's encrypted at rest, and you can encrypt it in transit in those pieces, you're really looking at data classification is an important piece of that. There's a lot of other things you need to do to really secure your data. I'll try and share this one more time and see if that works better. Are you able to see my storage dashboard now?
Yes.
Okay, perfect. So you can see it's still going through, it's still re-replicating everything. Eventually all the data will move to green. Right now it's still in a working state and it's still replicating it, but we are getting there, and given a few minutes more, it will get to a state where all the data has been replicated cleanly. This again is a nice way I can see it. A quick glance here, I can see, oh, I've got a system down, and I could go through as well and say if this is a node that's going to always be down, I can just remove it completely from the pool. So again, the challenge of open source always is that it's very powerful, it's very flexible, but having something that makes it easy to use like this is very helpful. And having a vendor package it all up and make it easy to work with and quick to deploy is also very important.
So Dan, quick question on, does this, the enterprise storage, does it dedupe for you, just the software itself?
In terms of at the file system level, like if I have multiple objects with the same file system, or if I have redundant data on a file system?
I believe so, yeah.
No, so if you're doing dedupe at the file system level, so again, when you're storing this via iSCSI on software, yeah, so if you're accessing it via iSCSI, you're essentially creating a block of data on top of software defined, on top of Ceph. It's a large block that's going to live there, and the underlying system, which is Ceph, doesn't know what's within that data or care. It's really just handling the replication side, so it's not going to natively do dedupe at that layer. That's where you really need some other products. So you typically see a lot of dedupe if you're doing backups to this, using it for archival purposes, but you're typically going to be using a third-party product for that. Does that answer that question?
Yeah.
Perfect. So I don't know how much of this you're able to see before. I'll go back through the interface a little bit here. But I've got my dashboard here, which lets me see all of the nodes that are joined to my storage environment and all the different roles I've assigned to them, whether that's just being useful as a web interface or it's actually a storage system. I could go ahead and repurpose some of these and assign them other roles. So for example, when that new node came in, this OSD4 I created, all I had to do was give it a name and tell it to be a storage node. I could have also done this if I was doing an OpenStack deployment. I could have made it a compute node or anything else. But in this case, I went ahead and made it a storage node. And then the only other piece I had to go in here is tell it now that it's a storage node. But so I've got my Ceph status here. And this other piece. So I can choose by default how many replicas to have of an object, what type, use the first disk if available, use all the disks. I can turn on SSL for my Rados access. So that was a question you had there. I can upload my certificate. I can make it secure that way for data at transit. So that's my web interface credentials. For Calamari, I'm not accessing it through SSL right now, but I absolutely could. And then we have these different roles. So Calamari is my web interface. That's what I'm looking at when I look at this tab. The others are the monitor nodes. And again, the architecture behind Ceph is such that the data lookups for knowing where data lives in the cluster all resides in this crush map on these monitor nodes. The OSDs just store the data. The monitor nodes are what store the metadata, or the metadata around how to look it up. Then, of course, we've got our Rados gateway, which is where you could set up iSCSI or however else you want to access the data. So you can drag and drop these nodes into whatever role you want. You could, add some more redundancy in different places, and that's really, how we make these pieces work and how we make them scale. And we've given enough time now to where even though we took that one node completely out of rotation, all the data is now back into a green state. Everything's replicated cleanly, and the system is going to be happy. So that was the bulk of the demo I had. If there's any other questions about the demo, I can certainly show more.
Yeah, we had a question, but it was more on the Ceph side of things. I think we're good with the demo, though, unless anyone else has more questions. So I don't know if you can see it, but it's can Ceph do drive tiering as well?
Oh, yes, great question. So architecturally, yes. So you can have an entire tiering of SSDs, so you'd have dedicated servers to handle. So yes, so tiers are important. So at the lowest level, if you want to improve your performance, and this is what we did for our own internal architecture, is you add an SSD for between every 4 to 7 spinning disks. and you put that on each storage device, and that's where the journal lives, and that really improves your write performance. It can also improve your read performance. You can also do write-back tiering or cache, and there's different ways of doing the tiering at a different level where you can choose, and for most workloads, unless you're at Netflix and you're streaming large video, the tiering becomes very easy. You're just standing up SSDs in front on tiering servers to speed up that performance. So that absolutely is something that's supported and heavily used to increase performance. Because again, this is very customizable. You could set up a Ceph environment with just the crummiest SATA drives you want, and the performance would not be good. Or you can go as far up the scale as you want from there with SSDs and everything else. So you get to determine what performance you need, and then base that on the cost. So you're in a lot more control of what that performance is going to look like and what the cost is going to be. So yeah, the question was about this Gartner report and the pricing here. I believe that is per usable terabyte. I would have to look into the exact report though to get those details. Those prices do seem a little bit high, so I'm guessing they're including the cost of usable storage, the cost of software, everything. They factored in the cost of everything there. And I think these are 5-year costs as well, so that's not a 1-year cost. So really the goal today was to talk about what are the reasons to look at software-defined storage, why we think Ceph makes sense, why we think SUSE is a great partner in the Ceph space, and it's a good enterprise distribution to go with. Give you a little bit of the architecture of it, a brief overview of what that looks like if you had it set up in your environment. But it's really just another way of looking at storage so that you've got the tools you need to be flexible and reduce that cost ultimately. At Novacoast, of course, we would love to be the ones to help you implement that or help guide you through different storage scenarios, because it's not as easy as just flipping a switch. There's a little bit to it. But yes, good question, Brandon, specifically around services. So services would be helping get it set up. It could be configuring it for growth. It could be adding capacity. It could be modifying the rest of your environment, putting the tools in place to make better use of it. We talked a little bit about DevOps and how to integrate that into a software-defined everything world. So there's a lot of different services we could offer around that. It's really just up to whatever it is you need.
Yeah, it's going to be around all the integration and any custom development. Making it work that's what Novacoast is going to do. We've done it ourselves here. We're also looking now into a broader software-defined everything, which includes software-defined networking and putting all those pieces together. So that's our next phase in our implementation, and we'll be sure to let you guys know, because it's a big idea, right? So this is one piece to software-defined everything, and the piece that you can do right now is storage. The rest will come.
So if no one has any other questions, I'll give you back 8 minutes of time. But I do appreciate your time today. I know it's busy fitting things into your schedule. Hopefully you learned a little bit. And if you have any other questions, please reach out to me or Hector. Again, I'm Dan Elder, and this is Hector Sanchez as well. And we'd love to talk further. If you have one-on-one things you want to go through, absolutely we can do that. We can dig into the demo. We can dig into individual use cases that really match up to your needs. But yeah, hopefully you learned a little something and this was useful for you.
Yeah, and expect a call from me or someone on my team. We just want to make sure you got all the information you needed, and if not, we'll take that one-on-one with Dan. All right, thanks Dan for the great presentation. Thank you everyone who took time out of their day to hear us out. Hopefully you learned a lot.
All right. Thanks all. Have a great rest of your day.